Okay, so unit 1, water and its treatment. So when we are talking about water, first of all, so water is, it's a natural resource, and it's a very important resource to everyone. And so it is a called as a universal solvent. Why? Because it is a very essential to everyone. And water molecular formula is H2O. Okay, so then next. So what is the importance of water? When we are talking about water importance, it is a very important, and it is then means we are using for various purpose. So in industrial wise and in domestic wise, and for then means here industrial wise means textile industries, each and everything, and then domestic wise is washing, bathing purpose, like this. Okay, so then what are the sources of water here? Sources of water means mainly from rainwater. Okay, rainwater. So then here, then this rainwater is again two types: surface water and groundwater. So surface water is nothing but, so which are present on surfaces. Examples for that means rivers and lakes. Groundwater, wells and springs. So then these are all the sources of water. And so then already I told, so importance of water. So living things, then each and everyone wants water. Why? Because it is a universal solvent, and it's a very valuable, and it is a gift of our nature also. And so then why one can survive for weeks without food, but one can't survive only for few days without water. Okay, so it is a very essential for existing of a human being, animals and plants. Even most of animals and plants also contain a large portion of water. For example, in our human body, 70 percentage of water is 75 percentage of water is present in our human body. And land plants. So then plants also in aquatic plants, 95 to 99 percentage of water is present in animal, water plants. So like this, so then each and every, that means here consisting of water, some percentage of water. And this is also useful for other fields like production of, that means the pharmaceutical industry, cement industry, textile industry, washing, bathing purpose, each and everything. Okay, so then next, so then here hardness of water, so impurities. So then that source of water which is gifted by our nature, it is a not a pure water, it consisting lot of impurities. So impurities means they are all in presence, like dissolved impurities, and then it's consisting of dissolved gases and suspended impurities and biological microbial impurities also. So dissolved, when we are talking about dissolved impurities here, inorganic salts like sodium, potassium, and metals, chloride, sulfides, these are all present in a water. That means your our natural water resource, that is natural resource. No? So then these are all the impurities present in our water. And then dissolved gases. Which gases are present in water means oxygen, nitrogen, carbon dioxide, oxides, and so ammonia, hydrogen sulfide. These are all the present in our, these gases are present in our water. And suspended impurities. Suspended impurities is nothing but sand and clay particles and organic substances. These are all present in water. And coming to this microbial and biological means pathogenic microorganisms. If we are drink this type of then directly water without any that means your purification, so then we are going to sick. So that means pathogenic microorganisms are present in water. Then we are take that water directly so in our into our body. So then we face a lot of problems, and it's gives up, that means it's diseases. So arises many diseases. Okay, so like this. And then next next one is so when we are coming to this that means your hard water and soft water. So then here when we are talking about, then two types of waters is there here. So then that is nothing but hard water and soft water. And what is the hard water and what is soft water? Okay, so then what is hard water and what is soft water? Hard water. Hard water means, so when we are, so see this. So this is nothing but hard water and soft water. Differences between hard water and soft water. Then Hardness. First, before going to what is hard water, then what is the hardness of water? Hardness of water means hardness in water is that nothing but it is a one of the characteristics. So then which is the one of the character for water which prevents the lather with soap. Okay. So then hardness in water is that the character which present in water then which prevents the lathering of soap. Okay. So why? What is the reason here? Why it doesn't give a lather? So because of the presence of a calcium and magnesium and other heavy metal salts dissolved in it. Already previously I told so a lot of impurities and dissolved salts are present in water. So due to especially calcium and magnesium, among all impurities, calcium and magnesium salts are very dangerous, and these calcium and magnesium and heavy dissolved metal dissolved salts are present in water. If they are present in water, then that water is a consisting of hardness character. Then that water is called as hard water. Okay, hardness is a property of a water. And what is a hard water means the water which does not give a lather with the soap is nothing but hard water. So this is nothing but when we are applying hard water on for bathing purpose, or when we are applying soap with the hard water, then what happened here? Then sodium is called as a, that means here calcium stearates, calcium soap. So calcium stearates. So sodium stearates is converted into calcium stearates, which is the white precipitate. Okay, it is a scum. So then it is called as a, so then means a white scum. So it gives a white precipitate. So then because of that, so then here then wastage of soap is takes place. And soft water means opposite to hard water, which gives a lather with soap readily like this. Soap water. Okay, so then which that means soft water which gives a lather readily with the soap, and then because of this there is a no wastage of soap is takes place like this. And then next so here, so hard water we are not used for this purpose. This means here we are it is not fit for bathing purpose, and then here bathing and cooking purpose, and then here drinking purpose. So these are these hard water is not fit for these purposes. Okay, and then next hardness of water. Already I told. So the property of water which does not gives a lather with soap is nothing but hardness of water. And then next, so this is nothing but hardness of water. And next one is here types of, when we are talking about types of hardness. Types of hardness means, so then two types of hardness is there: temporary hardness or carbonate hardness, permanent hardness or non-carbonate hardness. So temporary hardness. Then what is meant by temporary hardness? So temporary hardness means here two types of, already told, two types of hardness: temporary or carbonate. Means so then if water, so then which is consisting of carbonates and bicarbonates. Okay, na? So in water, so then if the calcium and magnesium, which metal salts, calcium and magnesium, carbonates and bicarbonates, or if they are all present, these carbonates and bicarbonates are present in water, then that water is consisting temporary hardness. Then so then here two carbonates, that means here carbonates and bicarbonates, they are all responsible for this hardness. So that's why this hardness is also called as carbonate hardness. Okay, so temporary hardness means temporary hardness due to the presence of carbonates and bicarbonates, and so because of this hardness is also called as carbonate hardness. And when these are, so magnesium bicarbonate, so that calcium hydroxide like this, so then the magnesium hydroxide is formed here. Okay, so this is nothing but water. Then it is a temporary hardness. And permanent hardness or non-carbonate. So then permanent hardness means, so then here temporary hardness, it can be easily removed by the boiling. Okay, and permanent hardness. Permanent hardness is also called as non-carbonate hardness. Why? Because so then here the absence of carbonates. So none other than carbonate salts of calcium and magnesium are responsible for permanent hardness. So that's why it is called as non-carbonate hardness. And due to the presence of chlorides and sulfates of calcium and magnesium. So then which salts are responsible for permanent hardness? Calcium and magnesium. Chlorides and sulfates are responsible for permanent hardness. And because of absence of carbonates here, we are also called as non-carbonate hardness. So we are also called as a permanent hardness as non-carbonate hardness. And how can we calculate the total hardness in any water sample means? So then when we are combined both temporary and permanent hardness, so the sum of temporary and permanent hardness is gives a total hardness of water. So this is nothing but about types of hardness. Then coming to the units of hardness. So units of hardness, when we are talking about the units of hardness, expression on units of hardness. So here, then units of hardness means here 4 units are there for water. So then what are there means here? So first one is the parts per million, milligram per liter, and then degree Clark and degree French. 4 units are present. So then here units of hardness are 4 types. That means here parts of ppm, mg per liter, degree Clark and degree French. And these entire units are converted in terms of calcium carbonate. So then hardness, especially we are expressed in terms of calcium carbonate. Why? Because so then calcium carbonate, it is a most insoluble salt. So then among all salts are present, all salts which are responsible for hardness, among all, we are expressed the hardness in terms of calcium carbonate. So then why? Because means there are 2 reasons for that. First reason is, so then calcium carbonate, its a molecular weight is 100. Molecular weight is 100 means it is very useful to calculations purpose. Okay, and that is a first reason. And second one is it is a most insoluble salt in water when we are compared with the remaining salts. So that's why we are express the hardness of water in terms of calcium carbonate. And these 4 units are converted into calcium carbonate. So that are they, those are all ppm, milligram per liter, calcium, degree Clark, degree French. Here, what is the ppm? Parts per million. What is the ppm here means 1 ppm is equals to 1 part of CaCO3. Okay, if 1 part of CaCO3 is present in any water, then it is nothing but, so it is nothing but here considered as a 1 ppm. So 1 ppm is equals to 1 part of CaCO3 equivalence hardness present in a 10 power 6 parts of parts. 1 ppm nothing but 10 power 6 parts of parts. If 10 power 6 of parts we have to take in the 10 power 6 parts. So 1 part of CaCO3 is present, then that is nothing but ppm, parts per million. Then coming to this milligram per liter, 1 milligram per liter is equals to 1 mg of CaCO3. Means if when we are talking about milligrams, okay, so here relationship 1 liter. 1 liter in weights we are considered as 1 kilogram. Okay, 1 kilogram is nothing but, here they mention milligram per liter. Okay, so we want these liters into, that means here milligrams means, then these liters, 1 liter of liters is converted into weight means, in terms of weight 1 liter water is equals to 1 kilogram. Then when this 1 kilogram is equals to how many grams? 1000 grams. So 1000 grams, when this 1000 grams is converted into milligrams means we have to multiply with the 1000. So 1000 into 1000. So then finally we got 10 power 6 milligrams. Okay, so then 1 milligram per liter is equals to 1 milligram of CaCO3 equivalence of hardness present in 1 liter of 1 liter of water. If 1 liter of water consisting 1 milligram of CaCO3, then it is called as a milligram per liter. And one here degree Clark, 1 degree Clark, that is equals to 1 part of CaCO3 equivalent hardness in 7000 parts. Here when we are considered 7000 parts of water, so in 7000 parts of water, so if 1 part of CaCO3 is present, then it is called as a degree Clark. Okay, degree Clark. And so next one is degree French. So degree French is nothing but, if 10, when we are taking 10 power 5 parts of water, in that 10 power 5 parts of water, if 1 part of CaCO3 is present, then it is called as degree French. So this is nothing but about a units. So then